Good day, I'm Brian Farrell, and welcome to PACE IT's session on Networking Services and Applications, Part 2. Today we're going to be discussing network access services, and then we're going to move on to other services and applications. As always, there's a fair amount of ground to cover, so let's go ahead and dive into this session. I will begin with network access services. The first network access service that I'm going to discuss is actually a piece of hardware, the Network Interface Controller, or NIC. It can also be called the Network Interface Card. The NIC is how a device connects to a network. The Network Interface Controller works at two layers of the OSI model. At layer 2, which is the data link layer, it provides the functional means of network communication by determining which networking protocols will be used, as in a NIC that will provide Ethernet communication or a NIC that will provide point-to-point protocol. It also provides the local network node address through its burned-in physical media access control address. At layer 1, the physical layer, the network interface controller determines how the network data traffic will be converted, a bit at a time, into an electrical signal that can traverse the network media being used, i.e., it provides the connection to the network. Most modern computers come with at least one built-in Ethernet NIC. Routers and other network devices may use separate modules that can be inserted into the device to provide the proper network interface controller for the type of media they're connecting to and the networking protocols that are being used. Another network access service is Radius, Remote Authentication Dial-In User Service. Radius is a remote access service that is used to authenticate remote users and grant them access to authorized network resources. It is a popular AAA protocol. That's Authentication, Authorization, and Accounting Protocol. It's used to help ensure that only authenticated end users are using the network resources they are authorized to use. The accounting services of Radius are very robust. The only drawback to Radius is only the requesters, the end users, password is encrypted. Everything else gets sent in the clear. Terminal Access Controller, Access Control System Plus, or TACACS Plus. Terminal Access Controller, Access Control System Plus. Boy, what a mouthful. It sure is easier to say TACACS Plus. Is a remote access service that is used to authenticate remote devices and grant them access to authorized network resources. It is also a popular AAA protocol used to help ensure that only authenticated remote network devices are using the network resources that they are authorized to use. With TACACS Plus, the accounting features are not as robust as those found in Radius, but all network transmissions between devices are encrypted with TACACS Plus. Let's move on to other services and applications. First up is RAS, Remote Access Services. Now, RAS is not a protocol, but a roadmap. RAS is a description of the combination of software and hardware required for a remote access connection. A client requests access from an RAS server, which either grants or rejects that access. Then we have web services, creating a means of cross-communication. Web services provides the means for communication between software packages or disparate platforms. It's usually achieved by translating the communication into an XML format, or Extensible Markup Language format. It is becoming more popular as systems diverge. Last up is Unified Voice Services. This is creating a better voice communication system. It's a description of the combination of software and hardware required to integrate voice communication channels into a network, as in voice over IP. That concludes this session on networking services and applications, part 2. I began by talking about network access services, and I concluded with other services and applications. Session on DHCP in the network. Today we're going to be talking about static versus dynamic IP addressing. Then we're going to move on to how DHCP works, and then we will conclude with components and processes of DHCP. And with that, let's go ahead and begin this session. And of course, we begin by talking about static versus dynamic IP addressing. So how does a computer know what its IP configuration is? Well, more than likely, a computer received its IP configuration from a dynamic host configuration protocol server. Not only did the server give the PC an IP address, but it also told the PC where the default gateway was, and more than likely, how to find a DNS server. A computer will receive its IP configuration in one of two ways, either statically, which means manually set, or dynamically, which means through a service like DHCP. Static IP address assignment works fine for very small and stable networks, but quickly becomes unwieldy and error-prone as the network grows and more nodes come onto the network. So let's talk a little bit more about static IP addressing. The administrator assigns an IP number and subnet mask to each host in the network, whether it be a PC, router, or some other piece of electronic equipment. Each network interface that is going to be available to connect to the network requires this information. The administrator also assigns a default gateway location and DNS server location to each host in the network. Now, these settings are required if access to outside networks is going to be allowed. That would be through the default gateway. And if human-friendly naming conventions are going to be allowed. And that way you can more easily find network resources, and that would be through a DNS server. Now, each time a change is made, as in a new default gateway is established, each IP configuration on each host must be updated. That's why it becomes rather cumbersome and complicated as the network grows. Now, with dynamic IP addressing, the administrator configures a DHCP server to handle the assignment process, which actually automates the process and eases management. The DHCP server listens on a specific port for IP information requests. Once it receives a request, the DHCP server responds with the required information. Now let's move on to how DHCP works. Here is the typical DHCP process. Upon boot up, a PC that is configured to request an IP configuration sends a DHCP discovery packet. Now, the discovery packet is sent to the broadcast address 255.255.255.255 on UDP port 67. The DHCP server is listening to that port. It's listening for that discovery packet. When the DHCP server receives the discovery packet, it responds with an offer packet, basically saying, hey, I'm here to help. Now, the offer packet is sent back to the MAC address of the computer requesting help, and it's sent on port 68. Once the computer receives that offer packet from the DHCP server, if it's going to use that DHCP server, it returns a request packet. That means it's requesting the proper IP configuration from that specific DHCP server. Once the DHCP server receives the request packet, it sends back an acknowledgement packet. Now, this acknowledgement packet contains all of the required IP configuration information. Once the PC receives the acknowledgement packet, the PC changes its IP configuration to reflect the information that it received from the DHCP server. And that's the typical DHCP process in a nutshell. Now let's talk about components and the process of DHCP. We're going to begin by talking about the ports used. Now I already mentioned this once, but I'm going to mention it again because you need to know this. The PC sends its discovery packet out on the broadcast address 255.255.255.255 on port 67. That's UDP port 67. When the DHCP server responds, it responds to the PC's MAC address, Media Access Control address, on UDP port 68. That's important to remember. The PC uses UDP port 67. The DHCP server responds on UDP port 68. Then there's the address scope. The address scope is the IP address range that the administrator configures on the DHCP server. It is the range of addresses that the DHCP server can hand out to individual nodes. There's also what are called address reservations. Now these are administrator configured reserved IP addresses. The administrator reserves specific IP addresses to be handed out to specific MAC addresses. Now these are used for devices that should always have the same IP address, as in servers and routers. If you didn't do that, there is the possibility that your default gateway's IP address might change. Now the reason we use address reservation is this allows these addresses to be changed from a central location instead of having to log into each device and change the IP configuration separately. Now part of the DHCP process are what are called leases. The DHCP server hands out that IP configuration information, but it sets a time limit for how long that IP configuration is good. This is called the lease. So the parameters are only good for a specified amount of time. Now the administrator can configure how long the leases are. There are also options that the administrator can configure. The first one that's pretty obvious is the default gateway location. There's also the DNS server address, and the administrator can configure more than one DNS server location. An administrator can also configure an option for the PC to synchronize with a time server. So the administrator can configure a time server address. There are many more additional options, but those are the big three that you should remember. Now when a PC boots up, it does have a preferred IP address. That would be the IP address that it had the last time it booted up. Now it can request that same IP configuration from the DHCP server. Now the administrator can configure the DHCP server to either honor that preference or to ignore it. Now, under the right circumstances, a DHCP server isn't required to reside on the local network segment. Now, as a general rule, broadcast transmissions cannot pass through a router. But if there is not a DHCP server on the local network segment, the router can be configured to be a DHCP relay. When a DHCP relay, also called an IP helper, receives a discovery packet from a node, it will forward that packet to the network segment on which the DHCP server resides. This allows for there to be fewer configured DHCP servers in any given network, reducing the amount of maintenance that an administrator needs to perform. Now that concludes this session on DHCP in the network. We started with static versus dynamic IP addressing, and then we moved on to how DHCP works and we concluded with the process